Greetings, my name is Leonelino, and today I will tell you a lot about licensing of a wearable multi-sensor user streaming platform. Definition: Wearable is the complete design of flexible multi-sensor user streaming platform integral for a variety of medical research and recreational applications. Topic 1. The design considers practical constraints as a wearable device and multitudes every month, aiming to satisfy developers, research, and user needs for reliability, power efficiency, use of a use and a functional developing every month.
In a clinical setting, stress, anxiety, depression, PTSD, they are all based on questionnaires, which could be very subjective. Stress hormones such as cortisol could be a very sensitive biomarker in this case to really quantify stress accurately. That's why in this work we introduce a laser engraved graphene structure that can rapidly quantify stress hormone cortisol in human sweat.
We had to test a few versions before this actually works, and it's like a glucose patch. You put it on your arm and wait for your sweat to accumulate on the patch. You add some reagents to help you to get the signal.
So when our antibodies recognize the cortisol, there is an enzymatic and electrochemical reaction. Several electrodes are produced that arrive to our sensor surface.
It takes 3 minutes for the signal to be transmitted to your phone or your computer.
The circadian rhythm of the cortisol is also important. Our cortisol level fluctuates during the day. In the morning, you get a high cortisol level, and in the afternoon, you get a lower cortisol level. But for the patient with PTSD or the patient with depression, their circadian rhythm is a bit different from healthy people. The important use of this portable wearable system is really allow us to track our stress level in our daily activity. We could identify the problem earlier,
and hopefully it can provide early warnings of our body's mental condition or even physical conditions.
One of the most important advantages of our system is the flexibility. It can be adapted to any part of our body in a very comfortable way.
Currently, if you monitor cortisol level in your body, you have to draw blood. But when you draw blood, you are actually inducing extra stress to the subject, making your measurement not accurate. That's why we think non-invasive cortisol monitoring will be very attractive. Right now, we are working on a NASA-funded project trying to monitor the chemical biomarkers such as cortisol and metabolites, as well as the physical biomarkers such as blood pressure and heart rate to monitor stress and anxiety level of the astronauts.
The way we modify the graphene surface can translate to the detection of all the types of biomolecules, so we only need to select the proper receptor to detect the molecule we are interested in. So we truly believe that our system could, in the near future, revolutionize the health management control.
Application in electronics are recent years, in addition to the technology for processing and designing support different types of wearable sensors and devices, such as accelerometers and gyroscopes, smart fabrics, and actuators and wireless communication networks have been developing for clinical research and health monitoring. in topic 1. Topic 2.
Wearable devices today are used for multiple of different applications which need to measure biopotential, optical and impedance measurements. To be able to support multi-parameter VSM applications, usually multiple analog front-ends are used. The ADPD 4000 is a multi-parameter VSM chipset which allows for impedance, optical, capacitive and temperature sensing into just one single chipset, which allows for a small PCB form factor, low power and is cost effective. One of the key benefits is that the ADPD 4000 has 12 time slots. In each time slot, a certain measurement can be operated without configuring it again. This reduces the architecture for a multi-parameter VSM dramatically. By using ADI's new biomedical front-end, the system flexibility goes up, whereas power, size and cost is reduced. If you would like to receive more information on the ADPD 4000, please visit our website.
Pros and cons. Pros and cons.
How to use the temperature sensor in my signals? First of all, power my signals. It goes directly to the configuration menu. Select offline mode in the menu and click on the Start Monitoring button. In the sensor selection screen, you can see all the sensors available. By selecting the temperature sensor, the icon will turn blue. Then, click on Data button to access the data screen and start visualizing the data. Click on the sensor icon to start real-time data visualization. Connect the jack sensor in the temperature connector in the My Signals device. Put on the armband and then put the sensor inside it in your elbow inner side, making contact between the metallic part and your skin. Now you can visualize temperature values in real time on the My Signals screen using the standalone mode. Remember, you can also send the data to the cloud by using the Bluetooth and Wi-Fi modes.
Pros. The platform is designed to make to the clinical detection environment more comfortable and meet the requirements of clinical signal quality. The innovation elements mainly encompass multi-sensor platform designs, now flexible material especially for respiration monitoring, the complex behavior verification methods and result analysis analyzers of the material, sensor and systems. Cons. Cons. For instance, one of the main problems in color ACG signals what detected electrodes is the heterogeneity of the scan electrode impedance. By how differing the impedance measurably disturbs the ACG data. Conclusion. The fatal body sensory is sparing the quality. Failure about aggressive development on many of the underlying technologies. Wearable inserted sensors are becoming commonplace on the consumer market, so the devices are fairly primitive in their recovery state. It was plain to see the significance of the role that they will play in the future of the whole car. Thank you.